Good afternoon, everybody. My name is Joanne Ting, and I'm the CEO and President of DataSeer, a startup based in Houston. Today, I'll be describing to you a tool we've developed to digitize industrial diagrams using machine learning and computer vision that transforms highly manual processes to semi-automated and technology-accelerated workflows. You might be asking yourself, what's so hard about data extraction from diagrams? First of all, diagrams are typically shared between organizations and also within organizations in PDF image format. Most legacy installations don't have diagrams digitized in CAD form. This makes simple tasks like searching for files or finding where something's located in a multi-page file really hard. Secondly, engineering standards are not hard rules. They are suggestions. Different project teams follow different conventions with liberal use of customizations. And finally, extraction and digitization of paper or scanned diagrams is today a highly manual and time-consuming process, since it involves a human engineer with domain expertise interpreting what's drawn and written on paper or on the image. In industrial systems, I went a page too fast. The previous slide basically talks about how in industrial systems, mistakes come at a high cost due to the safety critical nature of installations. Any kind of ambiguity needs to be interpreted and then resolved by a human engineer, who then carries responsibility for the work. To address this, we adopt a human-in-the-loop approach to allow engineer users to guide and override the ML tool. Here's an example in the next slide of a type of industrial schematic called a process and instrumentation diagram, also known as a PNID. You can see what kinds of things we might want to detect and recognize on the page: symbols, text attributes, tables, notes, comments, and connections. We can use both automatic and semi-automated approaches to get the best of both worlds. A fully automated model is suitable when the data distribution and training remains the same at test time. If you need a rough estimate of what's in the diagram and are willing to trade off accuracy for speed, then it's a good option. On the other hand, a semi-automated human-driven approach may be leveraged when the data distribution is changing over time. You can use this mechanism to solicit feedback from the user while also allowing the user to review extracted data. Our tool has two modes of operation. The first is a Deepnet model that, when applied, automatically recognizes symbols from a default symbol library. This global pre-trained model works really well for these predefined symbols, but does require lots of training data that's intensive to collect. Again, jumped a little bit too fast. Our second mode of operation, which you could see in the last slide, is one where it's human in the loop. We solicit user feedback in the application, allowing training data to be generated and models to be updated on the fly, based on what the user tells us we got right or wrong. We offer mechanisms to allow users to save their extraction preferences and any custom symbols so that they can reuse them in the future or possibly share them with others. In this way, we offer a tool that allows engineers to work in a collaborative fashion with technology, not only reducing time and error, but also making sure engineers spend time on meaningful, purposeful work. If you'd like to learn more about our tool or to see a demo, please get in touch with us at info@dataseer.digital. Thank you very much.